According to the National Electrical Code, specifically Section 314.28, A3, splice boxes are not permitted to be used as a junction box for branch circuit conductors. Furthermore, Section 314.28 C states that all splices and taps shall be accessible. The primary reason for these stipulations is that splice boxes are generally not designed to handle the high current and heat generated by 40 or 50 amp circuits. Using undersized junction boxes can lead to overheating, which poses a significant fire hazard. Additionally, the requirement for accessibility ensures that splices and taps can be inspected and maintained properly over time. Given these code restrictions, there are several alternative approaches one could consider. Firstly, one option is to use a junction box that is appropriately sized and has an adequate ampacity rating to handle the current of the circuit. Secondly, you could install a service disconnect at the new location and then run new cables from the disconnect to the circuit panel. This would effectively extend the circuit while providing a point of disconnection for safety and maintenance. Thirdly, you could extend the original circuit directly from the circuit panel using conduit or wire mold. This approach avoids the need for any splicing near the panel and maintains a continuous run of conductors. When selecting a junction box, it is essential to consider the ampacity rating of the conductors and ensure that the box is rated for at least that amount of current. The size of the junction box is also important to provide sufficient space for making the splices and for heat dissipation. In addition to the code requirements, it is always a good practice to follow industry standards and best practices when working with electrical circuits. This includes using properly rated connectors and ensuring that all connections are tight and secure. When dealing with high ampacity circuits, it is also important to use appropriate personal protective equipment, such as insulated gloves and safety glasses to protect against electrical shock and other hazards. Furthermore, ensure that the circuit is de-energized before working on it to prevent any accidental contact with live conductors. Always consult the latest edition of the National Electrical Code and any local electrical codes to ensure compliance with all applicable regulations. If you are unsure about any aspect of the electrical work, it is always best to consult a qualified electrician. Remember that electrical work can be dangerous, and it is essential to take all necessary precautions to ensure your safety and the safety of others. Using appropriately sized junction boxes and following proper wiring techniques can help to minimize the risk of electrical fires and other hazards. Always double-check your work and verify that all connections are tight and secure before energizing the circuit. In addition, it's vital to perform regular inspections of electrical systems to identify any potential problems before they escalate. This can include checking for loose connections, damaged wiring, or signs of overheating. By taking a proactive approach to electrical safety, you can help to prevent accidents and ensure the reliable operation of electrical equipment. When extending circuits, always consider the voltage drop that may occur due to the increased length of the conductors. Voltage drop can reduce the performance of electrical equipment and can even damage sensitive electronics. To minimize voltage drop, use larger conductors or consider using a higher voltage circuit. Another important consideration when working with electrical circuits is grounding. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Ensure that all electrical equipment is properly grounded and that the grounding system is in good condition. Also, consider the environmental conditions when selecting electrical equipment and wiring. In wet or damp locations, use equipment that is rated for those conditions. In corrosive environments, use corrosion-resistant materials. The National Electrical Code provides specific requirements for different types of environments, so it is important to consult the code for guidance. Furthermore, when installing new electrical equipment, be sure to follow the manufacturer's instructions carefully. This will help to ensure that the equipment is installed correctly and that it operates safely and reliably. In addition to the technical aspects of electrical work, it is also important to be aware of the legal and regulatory requirements. In many jurisdictions, electrical work must be performed by licensed electricians. Be sure to check the local regulations before starting any electrical work. Moreover, keep accurate records of all electrical work that is performed, including the date, the scope of work, and the materials used. This information can be helpful for future maintenance and repairs. Consider the load calculations for the circuit to ensure that it is not overloaded. Overloaded circuits can overheat and cause a fire hazard. If necessary, add additional circuits to distribute the load. When running new cables, be sure to protect them from physical damage. This can include using conduit or cable trays to protect the cables from being crushed or cut. Also, avoid running cables near sources of heat or moisture. In addition, when making splices, use properly rated connectors that are designed for the type of conductor being used. Avoid using twist-on wire connectors for large gauge conductors, as they may not provide a reliable connection. Consider using crimp-on connectors or other types of connectors that are designed for high-ampacity circuits. Moreover, when working with aluminum conductors, be sure to use connectors that are specifically designed for aluminum. Aluminum conductors can corrode if they are not properly connected, which can lead to a loss of conductivity and a potential fire hazard. It is important to use antioxidant compounds when connecting aluminum conductors to prevent corrosion. Furthermore, when installing new electrical panels, be sure to follow the manufacturer's instructions carefully. This includes properly grounding the panel and connecting the branch circuits to the correct breakers. Also, be sure to label the breakers clearly so that it is easy to identify the circuits they control. Consider using arc fault circuit interrupters or arc fault circuit interrupters for branch circuits that serve bedrooms, living rooms, and other areas where people are likely to be present. Arc fault circuit interrupters can detect arc faults, which are a common cause of electrical fires. Furthermore, consider using ground fault circuit interrupters or ground fault circuit interrupters for circuits that serve bathrooms, kitchens, and other wet locations. Ground fault circuit interrupters can detect ground faults, which can cause electrical shock. It is important to test ground fault circuit interrupters regularly to ensure that they are working properly. Use the ground fault circuit interrupter tester to verify that the ground fault circuit interrupter trips when a ground fault is detected. Be sure to replace any ground fault circuit interrupters that fail the test. In addition to the above, always remember that electrical work can be dangerous, and it is essential to take all necessary precautions to ensure your safety. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Remember to turn off the power to the circuit before working on it. Use a voltage tester to verify that the circuit is energized. Wear insulated gloves and safety glasses to protect yourself from electrical shock and other hazards. Work in a well-lit area so that you can see what you are doing. Avoid working in wet or damp conditions. Keep your work area clean and free of clutter. Use the proper tools for the job. Do not use damaged or worn tools. Inspect your tools before each use. Follow all safety precautions when working with electricity. By following these safety precautions, you can minimize the risk of electrical accidents and ensure that your electrical work is done safely and correctly. When working with high-ampacity circuits, it is especially important to be careful and to follow all safety precautions. High-ampacity circuits can deliver a large amount of current, which can be very dangerous. If you are not sure how to work safely with high-ampacity circuits, it is best to hire a qualified electrician. When selecting conductors for high-ampacity circuits, be sure to choose conductors that are rated for the current that they will be carrying. The National Electrical Code provides tables that specify the ampacity of different types of conductors. It is important to consult these tables to ensure that you are using the correct size conductors. In addition to the ampacity rating of the conductors, it is also important to consider the temperature rating of the conductors. The temperature rating of a conductor is the maximum temperature that the conductor can withstand without being damaged. The National Electrical Code provides tables that specify the temperature ratings of different types of conductors. It is important to consult these tables to ensure that you are using conductors that are rated for the temperature of the environment in which they will be installed. Consider using a licensed electrician for electrical modifications. Firstly, Safety is paramount. Licensed electricians possess the training and experience to perform electrical work safely and in compliance with codes. Secondly, code compliance is ensured by a licensed electrician, ensuring that the work meets all applicable electrical codes and regulations, avoiding potential hazards and legal issues. Thirdly, expertise and knowledge of a licensed electrician provides expertise and knowledge to accurately diagnose electrical issues, recommend appropriate solutions, and perform quality work. Fourthly, proper permits will be secured when necessary, with a licensed electrician handling the process of obtaining required permits for electrical work, ensuring compliance with local regulations. Fifthly, liability protection is offered, as hiring a licensed electrician provides liability protection in case of accidents or damages caused by faulty electrical work. Sixthly, increased home value is possible because properly done electrical work can increase the value of your home and make it more attractive to potential buyers. Seventhly, long-term cost savings are possible because while hiring a licensed electrician may seem like an upfront expense, it can save money in the long run by preventing costly repairs and ensuring the safety and efficiency of your electrical system. Eighthly, peace of mind is secured, knowing that a qualified professional has handled the electrical work, giving you peace of mind and reducing the risk of electrical problems in the future. Ninthly, warranty and guarantee are provided. Many licensed electricians offer warranties or guarantees on their work, providing added protection and assurance. Tenthly, access to the latest technology will be available as licensed electricians stay up to date on the latest electrical technologies and techniques, ensuring that you receive the best possible service.